3 randomly selected children are surveyed. The ages of the children are 1, 2, and 12. Assume that samples of size n equals 2 are randomly selected with replacement from the population of 1, 2, and 12. And so listed below are the 9 different samples, and we're going to complete parts A through D. So here are our samples. Let's go ahead and first open this up in a StatCrunch before we get to our first question. Okay, so the first column just tells us how many we have. So we have 9. Okay, the first column here, x1, represents the variable in the first one. So you can see here it's 1, 1, 1. So you have 1, 1, 1. And we have 2, 2, 2, 2, 2, 2, and then 12, 12, 12. And then in the second part, you have 1, 2, 2, 1, 2, 12. So 1, 2, 12. Then we have 1, 2, 12 again, 1, 2, 12, and then 1, 2, 12 again. Okay, so therefore, this is our data. Now, we want to be able to find the value of the population variance. And you can see here it says the population consists of the numbers 1, 2, and 12. So we're going to create a new column here, and we're going to call this population variance. Okay, and then we're going to put in those 3 numbers, 1, 2, and 12. So 1, 2, and then 12. All right, and so now what we want to do is we want to find the population variance of those 3 numbers. So we're going to go to Stat, and then select Summary Stats, and then go to Columns, and we're going to select Population Variance. Okay, now what we want to do is the following. Okay, we want the population variance. This variance represents the sample variance. So we want to scroll down and look for the unadjusted variance. The unadjusted variance represents the population variance. Okay, so once we select that, now we're going to go ahead and select Compute, and then there's our population variance, and then we need to round this to 3 decimal places. So it's going to be 24.667. So let's go ahead and do that. 24.667, and let's see what our result is. And that is our answer. Okay, now the next part, what they want us to do is they want us to find the variance of each of the 9 samples, and then summarize the sampling distribution of the variances in the format of a table representing the probability distribution of the distinct variance values. So that means we're going to summarize it in this table here. Okay, so we're going to come back to StatCrunch. All right, and so what we want to do is we're now looking at the rows. So if you look here, the first one is 1, 1. So there's 1 and then 1. And then the next one is 1, 2. And then 1, 12. So what we want to do is we want to be able to find the variance of the rows, okay, between those 2 columns. Okay, so what we're going to do now is we're going to go to Stat, okay, and then what we want to do is we're going to go to Summary Stats, and now we're going to select Rows. Okay, so the 2 rows that we want to select are X1 and then X2, and make sure you hold the control button down so they're selected over here. Okay, now what we want to do is we want to find the sample variances because these are samples. So we're going to go ahead and select variance here. Okay, and then we're going to say store in table because we want to put it in the table. So let's go ahead and do that. Okay, so here is our row variance, okay, and that row variance is dependent upon these values here. So the variance between 1 and 1 is 0. The variance of 1 and 2 is 0.5. The variance of 1 and 12 is 60.5, okay. Now what I want to do is I want to come up here and we're going to write this, the sample variances, because that's what they are. They're the sample variances. And what it does is it just distinguishes between what we're looking for in this column and what we're looking for in this column. Okay, so now what we want to do is we're going to go ahead and then sort the table in ascending order. Okay, and the reason why that we want to do that is because we want to sort this according to our data and how we put it into our answer. So if you take a look at what we have here listed, okay, we have 0 and then 0, okay? And then we have 0 here. How many zeros do we have? We have 3 of them out of a total of 9 sets of data, okay? So here we know that we're going to select 0 as our first number that we see is repeated 3 times. So we're going to put the probability in as a fraction, and we can see that's going to be 3 over 9. Okay, now because this is not reduced, we need to simplify this fraction. So if you check your answer with this fraction in there, it's going to say it's not correct because you haven't simplified it. So we're going to come back and simplify this fraction. Okay, now let's go back here. So the next number that we see is 0.5 and 0.5. And how many do we have of those? We have 2. So we're going to go ahead here in the drop-down menu and select 0.5. Then over here, we're going to put in our fraction of 2 out of 9. Okay, let's take a look at the data again here. We have 50 and 50. We have 2 of those. So we're going to select the number here, 50, and then we're going to put in the fraction 2 over 9. Okay, and then the last one you see is 60.5. So therefore, we have 2 of those. So we're going to put in here 60.5. And again, we're going to put in the fraction 2 out of 9 because that is the probability. Now we're going to come back up here, and then we're going to make sure that this fraction needs to be simplified as 1 over 3. Okay, now that we have all our information in the data table, okay, again, we see that this represents the variances and this is the probability. So we're going to check our answer, and there is our result. Okay, now it says to find the mean of the sampling distribution of the sample variance. So what that means is we want to come up here. Okay, I'm going to close out of here. And they want us to find the mean of this column. They're saying find the mean of the sampling distribution, meaning find the mean of the column of the sample variances. So we're going to come over here and select Stat, go to Summary Stat. Now we're going to select Columns because we want to find the mean of the sample variances. So let's go ahead and do that. We select Mean and let's compute. And then you want us to round this to 3 decimal places. So we get 24.667. So let's go ahead and do that. We get 24.667, and then there is our answer. Okay, now it says, based on the preceding results, is the sample variance an unbiased estimator of the population variance, and why or why not? Well, let's take a look. We found the mean to be 24.667. And we saw that the value of the population variance was 24.667. So therefore, we will say that the sample variance targets the population variance. So it's either going to be B or D. And it says, as such, the sample variance is a biased estimator of the population variance, or the sample variance is an unbiased estimator of the population variance. Okay, so we need to make sure that we understand the difference between biased estimator and unbiased estimator. So a biased estimator is one that deviates from the true population value, where an unbiased estimator is one that does not deviate from the true population parameter. So therefore our answer is going to be D.